Hello everyone, and this is Metin from Huawei Cloud, uh, Huawei R&D Turkey MSDC Department, Cloud DTSE. I am. Uh, Today, we are going to talk about machine learning and artificial intelligence fundamentals. I'm going to make an overview about those topics. After that, I'm planning to do an hands-on about deploying an real-time inference model on Huawei Cloud ModelArts service. I'm planning to deploy segment everything model. Uh, so if everyone's ready, we can start the training. So, so first, I want to talk about machine learning basics. Machine learning is a field of computer science that gives computers that ability to learn without being explicitly programmed. So as you can see, it's actually uh, part of two sections, training and prediction. So in this example, we can see we make a supervised learning with labeled data. We train our code with our machine learning algorithms. After that, we make prediction with the labeled data and test those metrics. And test if our model learned our data well. Uh, Hence, machine learning methods can learn from true training and make predictions. So there are actually lots of types of learning, as I mentioned earlier. Uh, at the end, I'm going to talk about Huawei services, modular service, but it's mainly going to be about artificial intelligence and machine learning fundamentals. So supervised learning and unsupervised supervised learning is actually trained with and labeled training sets, regression and classification. So, for example, email classification with the already labeled emails. Unsupervised learning is discover patterns unlabeled data like clustering and segmentation. So, with the windowing techniques or etc., you can show the right-hand side image. So making those clusters, predict those clusters, it's unsupervised learning type. So reinforcement learning is actually about learn to act based on feedback reward systems. So like learn, play, go, and we give reward or uh, on win or lose. So at the end, our model actually learn how to play Go. And recommender system seek to predict the rating or preference a user. So those are the actually uh, earlier type of learning methods, recommender systems, and deep learning actually. So first, in machine learning, I want to talk about the regression. Regression is a statistical procedure that determines the equation for the straight line that best fits a specific set of data. So when I say straight line, I'm talking about actually a simple regression. So as you can see, this is the red line is our best fit line, and the one with the green is our true line. So we starting from this line, and we actually going through the find best fitting line. How we are going to do that? So as I mentioned, it's simple regression. The regression models include one independent and one dependent variable. And any straight line can be represented by an equation of the form y equals beta x plus a constant a. where b and a are the constants, and x is the independent variable and y is the dependent variable. Y's value change depend to x's value. So y is the dependent variable. The value of b is called the slope constant, and determines the direction of the degree to which the line is tilted. And the value of the a is called the y-intercept and determines the point where the line crossed the y-axis. So when the line intercepts in the y-axis, it's our constant a. So it's actually show us the height of our line where it starts from the y-axis, and actually so when we are going to calculate this line, we consider the residuals. So when we start, actually we don't have this line, so we use a random line in the function in the two axis system, and with the residuals we calculate the residuals, and we are trying to actually minimize the sum of residuals, so now I'm going to talk about what is deep learning. So machine learning also is an artificial intelligence, but when we say actually an artificial intelligence, we all think about the deep learning. So deep learning is as I mentioned earlier, machine learning is a subfield of learning representation of data. Deep learning algorithms attempt to learn multiple levels of representation by using hierarchy of multiple layers. So as you can see from the image, so in machine learning, feature extraction and classification are the separate operations, and classification is automated with the models like linear regression, logistic regression. So linear regression doesn't classification, logistic regression, but in deep learning, also feature extraction, it's considered a part of a model. So when we are using deep learning model, we only need to give our input data, and we take our output data. If you provide the system tons of information, it begins to understand and respond in useful ways. So why is deep learning useful? So it's manually designed features are often overspecified, incomplete, and take a long time to design and validate. So it's actually really time consuming, and learned features are easy to adapt fast to learn. And deep learning provides a very flexible, almost universal learnable frameworks for representing world visuals and linguistic information. So it actually understands the complex model actually understands way more than our understanding. So most of the state-of-the-art deep learning models nowadays are black box. So we don't actually know what kind of information they are using, and what kind of actually complex levels they are, and they can learn both unsupervised and supervised learning. So, and effective end-to-end joint system learning, it's utilize a large amount of training data very easily and fastly. So as you can see, the Google Trends, it's from in 2015. It's very trendy deep learning models. according to machine learning models, but machine learning models are still used in the industry. So like before deep learning, actually, so when we give our input pixels to a model, we need to actually first extract handcrafted features like eyes, noses, etc. And so we make the analysis and feature extraction and concatenate into a vector. So like colors and etc. We concatenate into a vector. Then we make a linear classification support vector machines and get the answers. But nowadays, actually, we use uh, just give our input pixels and perform everything with a big neural network trained end-to-end. So we actually concatenate lots of linear classifiers. So Google Linet does that, did that, and actually just give our input pixels and we get the predictions very easily and train our model very easily. So keep perform enough processing so that by the time you get the end of the network, the classes are linearly separable. So as I mentioned, we just use lots of linear classifiers. So let's look at our deep learning neural networks. So we are going to actually examine the neural networks in the next slides, but I bet you all see these infographics. So we give our inputs, and after that, in each layer, we calculate our we actually multiply them with our weights and add our biases and put them into our activation functions in each layer. And at the end, we make prediction, and with those predictions, actually, we backpropagate and adjust our weights in this networks most of the time. So this is actually a deep learning architecture. Artificial neural networks actually inspired from brain nature, and artificial neural networks are very core of deep learning. So most of the time, artificial neural networks is the basic steps of deep learning, and they are versatile, powerful, and scalable. So they are ideal to tackle large and highly complex machine learning tasks like computer vision tasks and object detection, etc. And they are classify billions of images, powering speech recognition services, recommending videos, learning to beat world champions at the chess, Go, and other games, and etc. So first, actually, in order to understand neural networks, perceptrons, and you need to understand biological neurons. So as I mentioned earlier, they are actually inspired by the nature. And because of our time is limited, unfortunately, I'm not. But if you have some questions, I can answer at the end of the presentation. If we can actually understand how the brain works, we could copy and use machine learning and deep learning systems. The brain is an impressively powerful and complicated system. Yes, and however, the basic building blocks of brain are fairly simple and easy to understand. So there are hundreds of billions neuron processing units in our brains, and each neuron can be viewed as separate processors performing simple computation. We call this in deep learning models as perceptron. So macula and Pitts neurons. So first, in I don't know, I don't remember the time, but it's mathematically modeled neurons, and macula Pitts models model the neuron as in with these actually rules, a set of weighted inputs omega I that corresponds to the synapse, and adder that sums that input signals, an activation function, initially threshold function. So the thresholds with the given input and its thresholds the input and give the output. And it's decided whether the neuron fires for the current inputs. Nonlinearity that's implemented element-wise. Without it, two matrices could be collapsed to a single matrix, given again linear function. So when we actually implement element-wise without two matrices, it collapse and to a single matrix, and it gives us linear function. So it's nonlinear. And the Macaulay and Pitt neurons is a binary threshold device. It sums the inputs multiple byte weights and either fires or doesn't fire. And depending on whether the input is above some threshold, it's actually fire that neuron. And it's a very simple model. However, a network of such neurons can perform any computation that a normal computer can provide it. That the weights WI are chosen correctly. So we need to choose our weights correctly. So we are going to learn how are we going to do that. X1, X2, X3. So each input actually multiplied with the weights, corresponding weights. After that, they are actually summed up, and the activation function, it decides it fires or not. So as I mentioned earlier, activation function is then thresholds. Yeah. Our brains also work with ones and zeros like computers, yes. So this is the actual basics of the deep learning. So actually, so in the example, let's say x1 equals 1, x2 equals 0, and x3 equals 0.5. In real neurons, those inputs come from the outputs of other neurons through their snaps. Those snaps have strengths called weights. The strength of the weight snaps affect the strength of the signal. So after that, we sum that up and we sum them up and actually decide it's fires or not. So besides those weights, we also use bias. So this is a perceptron. Again, we give some input, but not only to one neuron. We give that to a layer of neurons. So it's a layer. So after that, we also give a constant input, and we calculate them again. And in this way, we decide which of the neurons in a layer fires or not in the perceptron. So this is just one layer perceptron. So what does the perceptron really compute? So it tries to find a straight line in 2D plane, in 3D, and hyperplane in the higher dimensions, where the neuron fires on one side of the line and was not on the other. So this is simply a decision boundary that perceptron tries to find. So as you can see, if it's fire or not, it decides. It's actually find a line in 2D and hyperplane in 3D. So multi-layer perceptron is actually majority of interesting problems are not linearly separable, as you can imagine. So multi-layer perceptrons actually comes handy in those situations. We saw before that problems can be made linearly separable if we increase the dimensionality of the data. In artificial neural networks, we can instead make the networks more complicated. Multi-layer perceptron learning in the artificial neural networks happens in the weights, as I mentioned earlier. So you need to actually calculate those words very carefully, and we are going to learn how we are going to uh, not in actually complex format, but how we compute those weights and add more neurons between the input nodes and the outputs and get more complex neural networks. So actually add more neurons between the input nodes and the outputs, like this mentions actually the layers uh, gives more complex neural networks. So as you can imagine, just one uh, this is an neural network architecture. So it only has one input layer, one hidden layer, and one output layer. Hidden layers actually are neuron or units. So if they have neuron or units, so these are actually fully connected layers, but it doesn't have to be a fully connected. Some of the neural networks are not fully connected, but these examples are two-layer neural networks or one hidden layer neural networks. And this is three-layer neural network or two hidden layer neural networks. So deep networks typically have many layers and potentially millions of parameters. So I bet you can see some large models, and they're named like 7B, 7M, 70B. So those B's are billions and 70 billions parameters they contain. So they are much more complex than this representation. So what are we actually trained? So we actually train our weights. So we try to calculate our weights with our data in networks. So as you can see, this is our hidden layer. So our hidden layer. So first, we give our inputs to each neuron, and each neuron actually sum that up and actually sum that up and give insight to an activation function. So it's sigmoid in this case, and it decides whether those neurons fire or not. So we are trying to adjust our weight, and in this image actually we have 4 plus 2 neurons. So these are output neurons. So we have 6 neurons, and so 3 times 4 and plus 4 times 2. We have 20 weights. So 3 times 4 plus 4 times 2, we have 20 weights, 20 weight parameters, and 6 bias terms. So we have 26 learnable parameters. So in training, we have actually, not all the time, but let's say we have some labeled batch data. And first, we forward it through the network, get prediction. And with the random weights, we actually keep them forward them through the network and get predictions. After that, we actually calculate the error. So let's say our model gives us 5, and our labeled data says it needs to be 1. So we take the actually difference between the prediction and target values and calculate the cost function. So in order to optimize, we need to minimize the error or maximize the error signal. So let's assume we need to minimize it. In order to do that, actually, we need to take integral depending on them, depending on our outputs, and we backpropagate the errors. So the backpropagations gives us actually how not integrate, we derivate and how our model derives with those weights. So we adjust according to those values and update the network weights. And we do this in every batch, every step. And so this gradient moves actually towards the local minimum of the cost function, and we don't want to pass the local minimum cost function. So if we give our parameters like learning rate too high, when we try to train our model, we can pass the local minimum, and again we can maximize our loss. So we need to actually adjust those hyperparameters carefully. So as you can see, so that when I say we take derivatives, so as if you remember, when we take a derivative of a parabola, it's just a line. So those line actually gives us how it's change. So it's derivatives, how it drives according to a variable. So dependent to the variable. So dependent to our loss function, and we try to calculate our global cost minimum when we train our models. So now I'm talking about activation functions. So more layers and neurons can approximate more complex activation functions. As you can see, when we use more neurons, our prediction is getting better, but if we use too much neurons, as you can see, it's overfit. And so we have different kinds of activation functions like sigmoid, leaky ReLU, tanh, max out, ReLU, and LU. So their actually their main target is actually decide it's those neurons are fire or not, but they have different kinds of usages. So then I want to talk about bias variance trade-off. So in the machine learning and deep learning models, actually, there can be lots of bias variance trade-off in training. So we can actually solve those trade-offs. So if you have high bias and low variance, as you can see, the target hit it at the same spot, but not the right uh, spot. So this means our model is underfit and high bias, high variance. As you can see, it's wrong and it's have high variance. And so we want low bias and low variance. So and low bias, high variance is actually this is so it's actually caused underfitting and underfitting problems. So learned hypotheses may fit the training data very well, even outliers noise, but fail to generalize the new examples. So as you can see, this is actually inadequate. So it's not a good compromise. And as you can see, some of the X's predicted wrongly. So when we try to actually and some of the O's in the actually wanted training. So our X's and O's separated with the good compromise, like in the second picture. But if it's overfit, when it's new data arrived, it can't predict wrongly. So as you can see in training, if variance is getting higher of our training data set, we are more likely to overfit. And our test data's error rate, it's getting higher. So we don't want to overtrain our models, and also we don't want to underfit our models. So we want to switch stop between them. So as you do you know, Huawei Cloud actually have an AI service called ModelArts. After the actually presentation, we are going to do an hands-on to deploy a segment anything model on the ModelArts service. So ModelArts actually is an one-stop AI development platform that enables developers and data scientists of any skill level to rapidly build, train, and deploy models anywhere from the cloud to the edge. And ModelArts accelerates end-to-end AI development and foster AI innovation with key capabilities, including data preprocessing, semi-automated data labeling, distributed training, and automated model building. So ModelArts actually has lots of components. XML actually, it's a codeless AI application development platform service of ModelArts. So you can create your own application of models using already built models and use them. So you can do data management with the ModelArts and labeling frameworks. You can use dev environment for actually development experience and testing, etc., and simplifying the development process. You can use the notebooks instances with the dev environment, and you can make algorithm management to obtain more accurate predictions results and select the proper algorithm to train your model. And you can make training management to not overfit and underfit your models, and enables you to create a training job with training status and manage job versions. You can also do versioning. Also, you can make AI application management, allows you to import all meta models, and you can deploy your services in real time or batch 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 inferences. So uh, actually, our my presentations, and so you can give feedback using this QR code. So if you have any questions, I can answer. I'll be glad if you give feedback to this training. Thank you, Abdullah. I can also answer maybe some questions if you have any. You can write it from chat. After that, we can continue with the hands-on. Thank you, Nejat. Okay. Uh, so let me prepare. So as I mentioned earlier, we are going to deploy and segment anything model on Huawei Cloud ModelArts. So I use actually an code from GitHub. So and actually it's actually predict make a segmentation work with neural networks and segment anything model, and it's actually uh, segment any object in the image. So in order to first deploy the application, first we need to actually create our application. So this is our main function. And I created and test API for this model. So if we request the slash segment root path URL, our actually algorithms work. Our model is loaded. After that, with the input box, we are going to mask and segment the objects in the image. So for this Modeland test a Docker file, first you need to create a Docker file from Python 3.9.18 base image. We set our working directory as code. After that, we create another directory under the code directory as a called stem images. Then we actually download our model inside that with the curl and install the requirement libraries in the requirement.txt file and update our operating system, update and install the packages, required packages. Then we copy our code in our local device to our Docker image. Then we start up our application, REST API application, with the Unicorn server inside the image container. So first, we need to build our Docker file, Docker image, with the created Docker file, and you don't need, please don't forget to run your application at the end of your Docker file. So let's say Docker build. So let's say Docker build. Let's give a tag called DTT demo. And we want to build in this directory. So as you can see, our building process is started and finished because it's loaded from cache, and I already built this Docker image. After that, we need to push this image to Huawei Cloud SWR service. So first, let's check our image built successfully. As you can see, DTT demo image is created successfully. After that, let's go to SWR service software repository Huawei Cloud. So in order to push our image to SWR service, first we need to generate login command and login it. Again, we paste the login command. Sorry. And we login successfully. After that, we need to upload through client. So let's select that. And in order to do that, we need to change our Docker uh, image's name with the Docker tag command. So let's copy it and paste and make some changes. As you can remember, our image name is DTT demo. Our tag is latest. And we need to give an organization name. If we don't have one yet, we can create from create organization, and let's just give a name called DTT demo. And it's created successfully. So we put DTT demo for our organization, and for our image name, I'm going to call DTT ML and give a tag version 1. So it says the latest doesn't exist. So let's check again our image name. So it's going to be latest, forget to, and T, and need to be pushed successfully. So let's check our images. And pushed successfully. So it created successfully. After that, we need to push our Docker image. Again, we copy the new name and call Docker push and take off our image, and we push to SWR. Now we can observe our VTT demo image in the SWR My Images section. So then we need to actually go to ModelArts service. Open ModelArts service from services, Huawei Cloud. In this section, we need to create an AI application first. So go to AI application page under the asset management and click create application. Then we are going to use a container image, but you can also load your model from from OBS, but you need to actually give the path of your model you selected here in your code. Also, you can get your model from the training job in the ModelArts. Today we are going to use a container image. After opening the My Images, we choose our image its version, and click OK. Then we are going to use an HTTP protocol because we didn't set up our OpenSSL SSL certificates, and we give our API's port number. So we can check. We give 88 port for our application. So let's write 8080. So we want to deploy our AI application as real-time service. But if you want batch service, we can also select it too. If we want to give a start command, so if we didn't give our start command in here, we can also use it in start command section to run our test API application, and we select create now. As you can see, it's status normal and it's running. After that, we easily say deploy, and in the deployment section, we select real-time service. So we can give our service a name. I'm going to call it service DTT. Also, we can activate auto stop. So in order to don't forget our real-time service continuously, we can give a custom or presetted auto stop, and it's after 1 hour or 2 hours or 4 hours or custom amount of hour. It's stop automatically and it doesn't charge a bill. We can also give a description to our service. Also, we can create a dedicated resource pool, but we don't have one. So we are going to use a public resource pool that Huawei Cloud provides us. Again, we choose our AI application, its version, and we can choose a specification that instance which will run our model. So we want a GPU device, and we select it. Also, we can set our timeout. So timeout a single model, including both the deployment and startup time, after 20 minutes. If our model isn't deployed and startup, it gives a timeout. We can increase or decrease those timeout values. So everything gets actually set it up for our application. And we can say next and submit. After some time, our model is going to be deployed. In order to not to wait, I already deploy our model beforehand. So as you can see, we can actually send prediction with our inference code to test our model. So our model takes a base 64 image and the bounding box as a body. So I saved already our body, image and bounding box parameters in a JSON format. So let me paste and start prediction. Means that request path, our request path isn't just the root. We are going to use the segment, as I remember truly. Yes, segment. Uh, so let's request another prediction. So as you can see, we get our encoded binary mask image. So if we decode, so let's try to decode it and save it. So let's copy our decoder from here, and let's read our file, JSON file. So we are going to read output.json file. And let's import B64 decode and encode our code. Let's run it. So we need to use JSON.read, I think. So sorry. I don't. So let's copy it. So we need to give it string format. Sorry. Sorry. Hmm. Need to create JSON again. We can call this res. So let's do this as 0. So we actually save our response file. So if we decode it correctly, we can actually see it. We get the correct output for our image. So that's all, one. So if you have any questions, I can answer them. I can answer some questions if you have any. So do you guys have any questions? You can give feedback to this training actually from this QR codes. I'll be glad if you give. Welcome, Necati. So we can actually finish this training if you don't have any questions. You can use ModelArts and actually develop and deploy your artificial intelligence and machine learning applications in Huawei Cloud ModelArts service. So if you have any questions, you can also reach me through from LinkedIn, etc. So that's all. Take a good care. Also, I would be glad if you uh, just use the CodeArts free service. So it's a DevOps service of Huawei Cloud, and uh, so it has a freemium version of it from your Huawei Cloud account. You can go to CodeArts service and get an free subscription. So it's all free, and you can actually use it for combining machine learning and AI with an and create your maybe MLOps project. So if you go to Codar service, if you don't have any, you can just get an free one and subscribe to it. So have a great day.